In this video, we will talk about quadratic applications. So everything that we learned about quadratics, we're going to apply them on these two different word problems. So here we have Marisol jumped off of a cliff into the ocean in Acapulco while vacationing with some friends. So her height as a function of time is modeled by this function. So they give us a quadratic equation already that we're going to be using. In this case, t is the time in seconds, and h of t is the height in feet, okay? So you can pause the video also if you need to write this question down, or you can take a picture of it, whatever you'd like to do. So part A says, how long will it take Marisol to reach her maximum height? So maximum is, Marisol is up in a cliff. She's right here. And basically what she's going to do is that she's just going to jump and then she's going to land on the water. Okay, that's basically what she's going to do. So there's going to be a point in time where Marisol has reached her maximum height. Okay, but we don't want to find the maximum height right now. We want to find how long will it take for her to reach her maximum height. Now remember, when we were talking about maximums and minimums, the first thing that we wanted to find was our x value. In this case, we have our t value. So the time that she will hit her maximum height will be t equals negative b over 2a. Okay, so here, negative b in this case is the 16 divided by 2, and then a, which is going to be this negative 16. Okay, this is going to give me 0.5, and this is in seconds. So in half a second, Marisol is going to reach her maximum height. Okay. Now part B. What was her maximum height? So now that we know the time in which she reaches her maximum height, we want to know what is her maximum height. So this 0.5, we're going to plug it back into our equation. So our maximum height at 0.5 seconds is going to be negative 16 times 0.5 squared plus 16 times 0.5. And then you're going to add it to 480. So here's where you might want to use a calculator. Negative 16, 0.5 squared plus 16 times 0.5 plus 480. That's going to give me 484 feet. So that is going to be her maximum height that she reaches when she jumps. Okay. And now let's look at the last question. So at what time did Marisol hit the water? Okay, so we know that in half a second, she's going to reach this point. So how long will it take her for her to dive into the water? Okay, well, when she's in the water, how high is she? Well, she's zero height, right? Because she's landed into the water. So her height is 0 when she hits the water. Her height is 0. So it's kind of like you're finding the x-intercepts. So you're going to have 0 is equal to negative 16t squared plus 16 plus 480. Okay. Oh, I forgot the t. Now at this point, you can try to factor it. If you can't factor it, I think the easiest way to go about it is to just use the quadratic formula. So we're going to say t is equal to negative b plus or minus square root b squared minus 4ac divided by 2a. So here we're going to have negative 16 plus or minus the square root of 16 squared minus 4a is negative 16, and then you have 480 divided by 2 times a, which is going to be this negative 16 again. All right, so you're going to have this negative 16 plus or minus. Now what's in the inside? So here's where you want to really go into your calculator. So 16 squared minus 4 times negative 16 times 480. In the inside, I ended up getting 30,976 divided by 2 times 16. That's going to give me negative 32 on the bottom. Okay. So now let's figure out what the square root is. The square root of 30976, you're going to get 176 divided by negative 32. Okay, so now notice that this is going to break up into two different things. negative 16 plus 176 divided by negative 32, then negative 16 minus 176 divided by negative 32. Okay, so the top one is going to be negative 16 plus 176 divided by negative 32. That's going to give me a negative 5. And the bottom one is going to be negative 16 minus 176 divided by negative 32. The other one's going to give me a positive 6. Now, which one do you think is the one that makes the most sense? Well, does it make sense for her to be negative 5 seconds into the water? No. Time can't be negative. So this guy is the one that makes the most sense. 6 seconds. Okay, so it took her 6 seconds for her to hit the water. Okay, from the cliff. All right, so now let's do this next problem. Okay, so here we are not going to be given an equation, and this is a really good problem because when you take calculus, you will have to come up with your own equations. So a backyard fencer wants to enclose a rectangular space for a new garden within her backyard. So she has purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section of the backyard as a 4th side. So what dimensions should she make her garden to maximize the enclosed area? Okay, so the first thing that you kind of want to think about is let's try to draw a picture of what exactly all of this is. So if you kind of think about her garden, she's only going to use 3 sides that need fencing. So this guy, all of this needs fencing. The 4th side doesn't need any fencing at all. She's going to use part of her backyard. So she's trying to save some money. Okay, so when you look at the word dimensions, it's basically telling you what should the length and the width be of this particular garden. Okay, so if you think of the length and the width, so let's say this is x and let's say this is y, well, this should also be x, right? Because assuming that this is going to be a rectangular field, both sides should be exactly the same. So what should all of these things, all of these sides be in order for her to maximize her area? Okay, now let's think about it. How much wire does she have? She only has 80 feet of it. So that means we're only constrained to this 80 feet. This 80 feet should be the addition of all of these guys, x plus y, because that's going to be all of the thing that's around, which is basically 80 is equal to 2x plus y. Okay. Now, what is the thing that she wants to maximize? Well, she wants to maximize her area. Okay. Now, what is the formula for the area? Now, the area of a rectangle is length times width. So in this case, will be your x and your y. Okay. Now, we have to somehow incorporate the fact that we need to put in this 80 somewhere in the area. So we kind of have 2 equations here. So what I'm going to do is I'm going to move this 2x to the other side. So I'm going to have y is equal to 80 minus 2x. And now what I can do is I can put this guy in here, because then I have the area is equal to x times y. Y in this case is 80 minus 2x. And then when you multiply this, you're going to get area is equal to 80x minus 2x squared. So you can see that now we have a quadratic equation here, okay, with the area and the x value. So how do I find the maximum? So here the key word is maximizing. So what we're going to do is use the same thing, negative b over 2a. X is equal to negative b over 2a. B in this case, remember, b is the one that has the x, which in this case is the 80. Negative, and then the 80 over 2 times a, which is this negative 2. So you're going to have negative 80 over negative 4. Okay. And then when you divide this out, you're going to get 20. Okay, so x, the feet and for these sides should be 20. So this guy should be 20, and this guy should also be 20. That's the dimension for that one. How do you find the dimension for the y? Well, what we can do is plug this into our other equation to figure out what y is. Okay, so if your x value is 20, your y value is going to be 40. So in order for me to maximize this area, you need the bottom part to be 40 and the sides to be 20. Now, what would be my maximum area? I know the question didn't ask for the maximum area, but we can easily figure it out because that's just the length times the width. All we got to do is multiply the 40 times the 20. How much square feet does she have? We'll multiply this together. You get 800 feet squared. So she has 800 feet squared worth of whatever she wants to put in here. Okay, so that's basically what you would do. So this is a really good application problem. Don't be surprised if you get one or both in these in your next exam.